Happy New Year to all of you. So we spent a few minutes just sharing some fun adventures that you had over the winter holiday, and boy, people traveled all over the place and had some really great times with friends and family. So that's wonderful, and it's nice to be back and see all of you again. So we started today with back into fractions, everybody's favorite thing. Remember, fractions are your friends. So we started off by just talking about if a mall had a third off sale, and then they offered an additional third off. How many fractions would that be altogether of the total savings? And we talked about how when you add a third, that it's two-thirds because you don't add the denominators. The denominator is the size of your piece. So just like one orange plus one orange is two oranges, they just happen to be thirds. So one third and one third is two thirds. And as Daniel said, if you added the denominators and got 2/6, that 2/6 is the same amount as one third. So it doesn't make sense to double one third and still get the same amount. So make sure you just add or subtract the numerators when you're dealing with fractions. So the sum of a third was two-thirds. And we said if an item originally cost 99 euros, what was the savings after both of the sales went into effect? So a third is two-thirds, and two-thirds of 99 would be 66 euro. So if you saved 66 euro, how much would you pay of the original price? Well, you'd pay one-third of 99, which would be 33 euro. So just some really easy numbers to get us started. And then for my Gestalt learners, my right brain kids, you need to know the big picture. How is this used in real life? So we talked about how one day all of you will no longer be living with mom and dad, and you'll be living on your own, and you'll need to pay for your own housing and your own food and your clothes and entertainment and your savings, and you might have investments, and some of you like to play sports and keep stats on your favorite sports players or games. And so in real life, as a consumer, as a person who manages your own portfolio, or as a person who might work in business, or a person who might have investments, as a person who loves to watch or be a part of any kind of athletics. Those are some ways that mixed numbers, fractions, decimals, percents are used in real life, and adding and subtracting fractions are part of that. So they are very useful in real life. So we started with this. I was in Paris over the holiday, and at one point we were 3 1/8 kilometers away from the Tour Eiffel, the Eiffel Tower, and then we were doing some more walking away from the Eiffel Tower, and then we were 3 7/8 kilometers away. And I said, what operation would you do here to find out how far we had walked? And you all agreed you would have to subtract, and then we just talked about 3 7/8 minus 3 1/8 would just give us 6/8 of a kilometer. So that was just how far we walked in that little 5 to 10 minutes, and that is the same as 3/4 of a kilometer. Remember, you can simplify 6/8 because they're both even numbers, so they're both divisible by 2. So remember, it's just grouping together each two parts that are shaded out of each two parts of the whole if it's a fraction bar, and we'd have 3 parts out of 4 shaded, and so 3/4 is the difference. And then we talked again about why you only add or subtract the numerators, because the denominators in a fraction or mixed number, the denominator means the size of the piece. So if I want to add or subtract fifths and sevenths, fifths are larger than sevenths. So I cannot deal with the numerator, the amounts of these that I want to add, until I break these all into the same size piece. So when you get a common multiple of 5 and 7, which is 35, I'm breaking each of my fifths into 7 parts. There were 4 shaded, and so each of those 4 parts have been broken into 7. So now I have 28 35ths. Each of my sevenths have been broken into 5 parts so that they're the same size as the pieces here. And that means that 3 of the shaded were also broken into 5 parts, so I have 15 35ths. And now that my denominators are the same, my pieces are the same size, and now I can add 28 and 15, which gives me 43 35ths. Now remember, 35 35ths is one whole, so this is more than one whole. So I want to rename it to a mixed number so I can better picture this amount. So it's one whole and 8 35ths left over. To find that 8 35ths, I'm just taking away 35 35ths because that's one whole. This bar means divided by, so 43 divided by 35 is 1 with a remainder of 8, and that 8 is out of sizes that are 35ths. So we get 1 and 8/35ths. So that is this amount renamed to a mixed number. To subtract these, the equivalent fractions are the same, but now I subtract the numerators, only the numerators, and I have 13/35ths for the difference. We talked about how you change. You need to be flexible in 6th grade and go back and forth between fractions and mixed numbers. You're going to see when we're multiplying and dividing fractions why it's necessary to be able to change this to an improper or simple fraction. And a lot of you know this little shortcut of doing 4 times 3 is 12 plus 2 gives me 14/3, but not a lot of you knew why you do that. Well, think about what 4 2/3 means. It means I've got 1, 2, 3, 4 wholes plus 2/3. I can rename each of these whole ones as 3/3, 3/3, 3/3, and 3/3. So notice I have 4 groups of 3/3. So when you do 4 times 3, you're really saying I've got that many thirds. That's 12/3. Plus I have an extra 2/3 right here. So 4 itself is 12/3 plus another 2/3 gives me 14/3. But you don't want to write this out every time. So the shortcut is just to say 4 times 3 is 12. Remember those are thirds. Plus 2 more is 14/3. The denominator doesn't change because those are the things we're talking about, thirds. It's the size of each piece. So now we wanted to look at a subtraction problem where there's a little bit of an issue here in that it's kind of like money. If I had 30 euros and 50 cents and I needed to spend 27 euro 75 cents, I can't do it with the money that I have. I can't tear up a euro note and make change. I literally need to make some change. So when you subtract these decimals, you're making change. I can't do 0 minus 5. So I have to borrow one group of 10, which is what this 5/10ths here. I'm going to borrow one group of that tenth and I'm going to trade that 1/10 into 10/100ths. So when I borrow from that 5, I'm renaming that 5/10ths as 4/10ths and 10/100ths. So this becomes a 4, and I put my 1 here to make 10, and now I can subtract. 10/100ths minus 5/100ths is 5. I can't do 5 minus 7, so I have to go over and borrow one whole from my 30, leaving me with 29. This one right here is that one group of a tenth because I'm going to trade my one whole into 10/10ths. So I have 10/10ths here, and the 4/10ths left over makes 14/10ths here. So now I can do 14 in the tenths place, 14/10ths minus 7/10ths, which leaves me with 7, and 29 minus 27 is 2. So in borrowing and renaming and regrouping with decimals, it's the same exact idea for fractions, but fractions are actually easier. So first thing is this problem was really 30 1/2 minus 27 3/4, as you'll see on this page. So it was 30 1/2 minus, whoops, I think I erased. Let me go back here. So this was the original problem, 30 1/2 minus 27 3/4. So the first thing I have to do is make sure that we've got the same size piece. So how many quarters is a half? And you all knew it was 2/4. So my problem becomes 30 2/4 minus 27 3/4. And just like I couldn't do 50 cents minus 75 cents, I can't do 2 minus 3. So I have to borrow from my 30, and that would give me 29 euro, and I rename that one extra euro as 4/4. So that extra euro that I'm trading in is 1 euro, and 4/4 is 1 euro. And that 4/4, and I also have this 2/4, added together give me 6/4. It's like trading it in for quarters. So notice that what I want is the same denominator, and notice I'm adding 4 and 2, which is the same as the numerator and denominator here. A little shortcut is to think, I'm going to borrow from that one whole, and I'm going to make it 4/4, which is that 4 right there, because 4/4 is one whole. So if I just add 2 and 4, I get 6/4. So you can just look at these. That's what I'm going to add. It's a shortcut of adding this, 4/4 and 2/4. So now I have more change because that 1 euro, I've traded it in for 4/4. And I already had 2/4, so now I have 6/4, and now I can subtract. 6/4 minus 3/4 is 3/4. I'm just subtracting the numerators, and I no longer have 30. I have 29 euros. Minus the 27 gives me 2 3/4. And notice that 2 3/4 is the same amount as 2 75/100. Exactly the same amount. So first I had to get the same denominator, rewrite 1/2 as 2/4, and then I have to regroup, borrow €1 from my 30, leaving me with 29, and reorganize that €1 into 4/4 so I can add my 2/4, and that gives me 6/4, and then I can do my subtraction. So then we talked about if I've got these three different denominators, how do I get a common denominator for all three? And I can list all of the multiples of 9 and 4 and 3 until I get the same number in both lists, but a shorter, much easier, much faster way is just start with the biggest number, 9. List the multiples of 9 until you find a multiple of 9 that is also a multiple of 4 and 3. So I start with 9, which is a multiple of 3 but not 4. 9 times 2 is 18, not a multiple of 4. 9 times 3 is 27, not a multiple of 4. 9 times 4 is 36, and 4 times 9 is 36. 3 times 12 is 36, so I know that 36 is a common multiple of all three of these denominators, and that's what the least common denominator is. The smallest multiple, 36, of all of the denominators. So now I can rename 7/9, 3/4, and 1/3 all into 36. Use the multiply pattern that we've done over and over again. And I want to subtract the first two, so 28/36 minus 27/36 is 1/36. And then I want to add 1/3, and 1/3 was 12/36, so my final answer is 13/36. Then we played a game, heads together, heads apart. Teams 1 and 4 won the game in period 3, but it's to help you each practice individually and then compare your work with each other in a fun way. So we started off by just renaming all of these to simple fractions. So remember, this is like 4/4 and 4/4, or 2 times 4, 8/4, plus 3 is 11/4. 5 times 10 is 50, plus 6 is 56/10. Remember, this is 50/10 plus 6/10. 8 times 5 is 40/5, plus 3/5 is 43/5. So we went from a mixed number to a simple fraction, and then we went from a simple fraction to a mixed number. Remember, this means divided by, so this is like 17 divided by 3. I want to know how many thirds are in 17 thirds. So I can get 5 groups of 3/3 out of there because that's 15 thirds, and I have 2 left over. And that 2 left over is your numerator, and we're still talking thirds out of every group of 3. So 17 thirds is 5 2/3. Check it by going the other way. 5 times 3 is 15, plus 2 is 17 thirds. We know we're right. 41 divided by 8 gives me 5 groups of 8/8 with 1/8 left over. And 58 6. 58 divided by 6 is 9. 9 times 6 is 54. 54 from 58 is 4 left over. So I get 9 whole groups of 6/6 with 4/6 left over. And that's the same, if I simplify that, as 9 2/3. And then we were practicing adding and subtracting. So first thing you have to do here is rewrite them with a common denominator of tenths. And now I add 5/10 and 8/10, and I get 13/10. 3 plus 2 is 5 wholes. But 13/10, remember, is the same as 1 3/10. And that 1 is a whole that I add to my 5 to get 6 wholes and 3/10 left over. I'm adding here, first rewrite 2/5 and 1/3 in 15, so you've got the same size piece. Add my 6 and 5, I have 11/15 with the whole number 6, so 6 and 11/15. Rewrite both of these in eighths, but I need to have enough eighths so that I can subtract. I cannot subtract 1 minus 5, so I borrow 1 whole from this and I rename it to 8/8. 1/8 and 8/8 is 9/8. Remember, the shortcut is just to add these together because it's like adding my 8/8 and 1/8, and I get 9/8. And now I can subtract. And then I rename my 4/8 to a half. So my final answer is 1.5. And make both of these 8s. And again, I cannot subtract 2/8 minus 3/8. So I borrow 1, which leaves me with 5. And that 8/8 and 2/8 makes 10/8. And now I can subtract and get 7/8 with the whole 2. So 2 and 7/8. 4 minus 2 and a fifth. I have to get some fifths. I can't subtract 0 minus 1. So I need to actually rename my 4 as 3 and 5/5. 5/5 is 1. 1 and 3 is 4. So I haven't changed the value here. But now I can subtract and get 1 and 4/5. And I gave you this one at the end just so you'd remember that you don't always have to rewrite it with the common denominator. There already is the same denominator, and you don't always have to borrow. So 5/4 minus 5/7 minus 4/7 is 1/7, and 15 minus 13 is 2. Excuse me. And I had you practice one where you had to do 3 fractions with the common denominator. So if we list the multiples of 8, by the time we get to 8 times 3, 24. 4 times 6 is 24, so we know that 24 works for all of them. Use your multiply pattern, times 6 times 6, times 3 times 3, times 8 times 8. And now I've renamed all of these. I'm adding these two first, which gives me 21/24. And now I can subtract my 1/3, which is 8/24, and my final answer is 13/24. You have a choice on your homework. Please remember to fold your paper in half vertically, go down your paper, show all your work, and I'll see you next class.